Good evening once again. And so we have with us today Professor Pankaj Datta from IIT Bombay. He's a professor in data science. Actually, he's a professor with SGSOM Bombay, Decision Sciences and Operation Research. His research interests are supply chain optimization, reverse logistics, data analytics, and e-commerce. So, sir is currently the professor at SGSOM. Previously, he was a visiting professor, University of Berlin, visiting scientist at KIT, Germany. Also, he was the associate professor from 2014 to 2021 at SGSOM itself. He got numerous fellowships, including Swiss Government Fellowship, DFG Research Fellowship, DART Bilateral Exchange of Academics, Young Scientist Scheme, INSA Visiting Scientist Fellowship, a Departmental Award for Excellence in Teaching, and many Best Paper Awards and other fellowships. So, sir has completed his postdoc from EPFL, Switzerland, and PhD from IIT Kharagpur. So, it's actually our privilege to have him as an expert speaker. So, thank you very much, sir, once again for accepting our invitation. Our participants are really lucky to have you as our speaker. And since we are covering diverse domains in supply chain management, your talk will be an encouragement for all of us to further work in this field. Thank you very much, sir. Thanks once again. Over to you, sir.
Thank you, Professor Arun, for giving me the opportunity to talk for this particular workshop or say training program. Hello, participants. Arun, I am audible to you, all of you?
Yes, sir. You are audible. Yes.
Is my voice is fine?
Yeah. Yes, sir. Perfect. Sir.
So today, since this is a 1 hour session only, and there are several other faculty who will be covering different aspects of supply chain, maybe introduction of supply chain analytics, technological aspects of supply chain, and multi-category aspects of supply chain, and supply chain different type of nitty-gritty of modeling, etc. What I will cover today, since it is not a research talk, since it is more of a mixed of faculty development program as well as the research scholars who are attending here for their research purpose. So I'll give an introduction or say mapping between two aspects I'll cover, specifically how the supply chain network design are being done, the introductory part, the basic concepts, and how optimization is linked to design a supply chain. Though this program is a part of Gati Shakti, PM Gati Shakti initiative, so we will concentrate only on supply chain today, and I will try to map how the optimization aspects of supply chain can enhance the transportation and the distribution and the overall efficiency of a supply chain. I will also cover, a case application, that introductory information of supply chain network design, and then just a second. Introductory aspects of supply chain network design, and then say modeling process, how it is been done, how the basics of modeling process can be done in the context of supply chain, and then optimization can be brought in, and then how it can be optimized using sample example. I'll show you very basic examples so that all the research scholars and the faculty who is teaching that supply chain optimization, supply chain network design, supply chain modeling, supply chain analytics to their students or to their college level, so they will get some advantage of it. I'm sure many of you know a little bit about it, but today as a part of this session, I'll cover all these aspects one by one with basic level. Then I will show you how the good distribution can be done with 1 or 2 sample examples as a part of application of supply chain network design and an optimization process. And then we'll go to a case application, a real life case application of a milk industry. Whatever we'll learn, say in first 30 minutes or so, we'll see how it can be applied. I could have taken a large scale global supply chain, etc. as a case application to understand how this research been done. The basic level, how the first year PhD students or the initial level teaching can be done to PhD scholars, also MTech students, etc. So this way I have prepared the presentation today. So let's go one by one. So all these 4 aspects we'll cover in our discussion and the talk. So first one is the supply chain network design. There are many aspects of supply chain. So since it is only 45 minutes or 1 hour talk, so I cannot cover many things. Despite of that, I have tried to put few important aspects of optimization and the modeling part of network design of supply chain. So here, supply chain network design, you can understand that, in any supply chain, whether you do the coordination part, you give the introduction, demand planning, you do the supply side enhancement, or the more better relationship with them, social sustainability, whatever you want to do, you need the entire supply chain process. For that, you need a good network. If you have a good network, you can optimize your cost, you can enhance the performance, you can enhance the service level, and you can reduce the risk also. So many aspects can be covered if you design a good supply chain network. So the question is that when you design a supply chain networks, who are the entities that involved in supply chain network design? The entities are that, I can tell you the name in the next slide, it is there, but here you can see the synonym of the entities, the layman name of the entities, that the plan, source, make, deliver, and return. So here everything is there actually to some extent in the entire supply chain management aspects. Like plan means you need to design the process and you have to do some tactical planning, strategic planning, etc., which is a part of network design, because you have to optimize. You cannot design only, you have to optimize that also. So their plan will come under the big heading. And then source, that means supply part will come, whether it is a supply, raw material supply, whether it is finished goods, products, shipment, etc., there is a need of source, so that is called source. Then make means manufacture or produce the product. Deliver means good distribution, you distribute the product to the distribution center or through e-commerce supply chain. These days it is very popular now, everybody is shifting to the e-commerce and the delivery process also. And then return, the product return is also a part of supply chain, so that you can optimize your supply chain process, because without return you cannot optimize your cost. So these are the major part of a supply chain management, components of supply chain management. Under that you can see what could be the different echelon of supply chain. Here we can see the echelons of supply chain. First is the supplier, and then plan, or maybe you can say the manufacturing plant, manufacturing center, production planning, production plant, whatever you can say, it is the product has been produced. And then supply will provide the raw material. And then once the product are produced, packet, everything is ready, then product or maybe finished products may go to the downstream supply chain. So it will go to warehouse, and then from warehouse to distribution center. It can be located in anywhere in the center, in the country or the region that you are doing your business. It can be local supply chain, it can be hyper local supply chain, it can be global supply chain also. So and then you ship the product to the customer zone or retail zone, etc., where you can customer can buy the product. So this way you can prepare your echelon. So that you can see there are different stages of supply chain happen. One is the upstream supply chain, where you can plan your decision variable, like plan location, where to set up your plant, because it's a part of network design. How many plants will be there? What will be your raw material procurement planning? What could be your capacity utilization and production planning? All these you have to do before you start your production and deliver the products. So initial stage designing is required. Once that setup is ready, from whom you will buy, could be a capacity planning, what could be the inventory turnover planning, all these things you should prepare well in advance. That is called design stage. Now once the design stage are done, then you go to the control variable. That means the inventory, how much you to produce, how much to ship, how much to storage, who are the customer zone, through which how you should ship, how many modes are there. These are called in the next level, the control variable, which you can control to meet your demand. And then the objectives of the system can be to because you have to optimize the supply chain. The objective could be maximize the profit, minimize the cost, achieve the desired supply service level in the customer zone. You can minimize your financial risk. So many objectives you can put under the umbrella of network design. All these things, stage 1, stage 2, and the objectives, all three you have to put together before you design a supply chain network. So keeping that background, what we need to do in a supply chain network design process? First, clearly define your objective. That what, suppose if you are focusing on a container supply chain, you focus what you have to ship. Are you planning to ship say GMPT port, or say Mudra port to say Shanghai, or say to some extent Singapore, etc., or you want to ship from there to inland to Pune, to Surat, or say to Jaipur? So that you have to decide, and what product you want to ship, how many containers will be there. So all these things will be part of your objective. In which mode you want to, whether you want to use road or you want to use rail, etc. All these things will come under your objective. So once that is done, and then you need data. Then you collect the data. That means how many products needs to be sent, what are the previous informations you do have. That will help you to design your supply chain, because you have to design your supply chain before you start initiating your distribution process. So based on the past history, past data, you have to plan your network design. So that supporting data are required to enhance your knowledge of that subject and to design a better planning. You might have Excel data, you might have raw data. Based on that, you think what is the best planning you can do, and then design your supply chain network. Start planning your network plan design. For that, you need a model, because only designing cannot be done. You in Excel, if you open Excel and the data you have, you cannot design some rough planning of etc. You need a structure planning. You have to do a structured network planning, because once you design your supply chain network to optimize the supply chain management, so the supply chain process. So in that case, you cannot do the network planning day by day basis. You cannot do for every product by product basis. You have to set up a planning for say 3 months, or say for a particular product you have to lay out a design planning. That is called supply chain network. So that network has to be set up well in advance. You cannot change it every day basis. Otherwise, you cannot optimize your process. So in order to do that, you need a structured thought process. That structured thought process will come if you design a model, supply chain model, and then based on the supply chain network that you are planning to propose. And then you optimize the model. You can see the analyze the model. That is called you optimize the model using the data and using some optimization technique or simulation technique. You optimize your supply chain process or supply chain model, so that in the entire network you will get the best route, best container, like vehicles, how much vehicles you should send, how many quantity you should send, what will be a total cost. All these will come once you analyze the model after designing in stage 3, and then implement and refine your model so that it can be implemented to the organization for next 6 months or 1 year, say, and you can review it at a later stage. So this way you can optimize your supply chain network design. Every company who are today in our competitive world, they cannot design their supply chain on a daily basis. Even they cannot set the supply chain network, the optimum network planning for a longer period. Every quarter or 6 month basis or say 1 year basis, they have to modify, they have to review the process. So these 5 steps has to be done every 6 months interval, say, for every company, so that they can optimize their supply chain process. Even if it is whether it is like say in aquaculture, aquafish domain, many people are are doing this type of supply chain network planning for their fish distribution, meat distribution in the network, as well as in domestic as well as the global export level also. So they are facing this issue of network optimization. So here we will focus on this part of network optimization with the basic examples. So this you understood that this is general network, but among this network you can see among this network who is the best. Should you use both plant, both supplier, or only one plant? There are 3 options of route. Which route we should use? Which warehouse we should keep? Where to set up the warehouse? So many questions may come in a supply chain network design. So now, if you come back to the questions like point of discussions, so introduction I have given. Now I will focus about the modeling process. Suppose you have an objective of network design. You want to design a supply chain, but supply chain network. But for that, what ingredients you require so that you can develop a supply chain network? You might say that, sir, will you study today a big supply chain case, etc. No, we'll study a very basic supply chain case. But before that, we need to understand how the optimization works, how the network process work actually, modeling process works. Then we'll see a couple of examples of good distribution and then supply chain network design under disruption milk industry. So now, this if you come to the second point, the modeling process and optimization, which will help you to address point number 1. Let's focus that part. So modeling process. Effectively, as I mentioned with a couple of examples, that you have a management situation. For example, suppose Reliance will not like the top management will not understand that how to optimize the distribution. They have the basic strategical planning. The data scientist, the optimization team, the R&D team, the operation research team, the supply chain team, they will do this optimization process, the network design process. How many product to shift, in which route we should shift, what will be the cost. These parts are not being done by top management, but the problem will be given by them to the team, R&D team. So suppose you have the problem, say good distribution of a auto industry, or say say crude oil distribution of say Reliance, or say ONGC from say Bombay hub to Vizag, or say Bengal port through sea route. So suppose this is a problem. How many vessels are required? In every vessels, how much cost is involved there? What will be the best route optimization, best planning? So this is called the decision problem, management situation. You need to study that based on these 5 points. Based on these 5 points, you need to, based on the data, the previous problem, you have to think what is the actual problem of the company. So once you understand the management problem, you have to use some optimization technique or the data-driven decision-making planning so that you can analyze the problem in your language. That language top management won't understand. Only R&D team can understand it. You as a decision maker, you as a researcher can understand that. That is called decision making process. Next slide, I'll show you. And then implement the result. This implement actually is a layman language through which you can express your solution to the management. Management will understand the layman language, qualitative language, not the quantitative way, which you have solved from your decision making process. So these 3 steps are not only important in supply chain, it is important in any decision-making process using data as well as using the optimization techniques. Now, if you elaborate this part, you can understand, look at this particular 4 box here. So these 3 box, I have now split it into 4 box in a modeling process of supply chain or any design planning. So here you can see like data, like decision science planning. So here you can see this is the management problem. As I mentioned, say crude oil distribution of through vessels from Bombay hub to different location, right? Suppose this is a problem. So management situation. Now you have to design a symbolic model where you will have number of vehicles, some number of say vessels, and say quantity of crude oil. So that is your decision making, right? How many products are there? It can be multi-object, multi-product distribution model also. So these are your symbolic, or that you have to decide in terms of number of variables, number of assumptions, parameters, etc. That you have to define based on the problem study. That is required. That you can do once you study the model, the past model, past practice, behavior of the problem, and the data. You can design the structure, general structure, because you have to design a general structure so that if this is changed or some data are being changed, you can use similar model and you can replicate the process. Okay, because for problem to problem you cannot solve. You have to you cannot solve all real life issues. You have to design a general structure. Based on that structure, you can implement. For example, if you join tomorrow Reliance, say Maruti Suzuki, you have to come up with a general structure of optimization process. For every problem, everyday problem, you cannot design every problem. So you have to design a general structure. That is called general symbolic model. So once you have defined it, then you need to analyze it. But how will you analyze it? You need some techniques, supply chain optimization techniques or the analytical techniques. So there may be linear optimization are there, non-linear optimization there, integer programming are there, and then multi-objective optimization there, heuristics algorithms are there, meta-heuristic designs are there, simulations process are there, data-driven statistical analysis are there. So use all of them. Whatever you think, you can propose hypothesis, you can design modeling optimization, whatever you want. You analyze that. So once you analyze the structure, suppose you want to solve a waiting line analysis of a railway system. There you might not require too much of optimization. You might not too much of statistical analysis. You need queuing theory, waiting line analysis. So you use that. Whatever the model it is relevant, you use corresponding solution process. You bring it. Then you solve that. So that is called analysis process. So once you do that, today I'll show you optimization aspects of modeling. But you can, for different problems, you can use different aspects also. So then you go to the results. That result is your results. Convert that result into a decision-making process which management can understand, and then pass that intuition to the management. Effectively, you have solved the problem of Reliance crude oil distribution. You have solved the problem of say Maruti Suzuki. You have solved the problem of say any other product that you want to solve, address. This is what called the modeling process for every problem, not only for supply chain management problem. It can be applied for any other problem under the aspects of optimization and the data-driven decision-making process. Now, I will show you the optimization aspect, as I mentioned, network design. So therefore, I will show you some more deeper aspects of modeling, how modeling can be used to develop a supply chain problem. I repeat, how the modeling can be used, mathematical optimization can be used, basic optimization technique can be used to address a supply chain problem. For that, we will concentrate on supply chain network design and supply chain optimization. Let's see. So now the basic optimization model, only basic part I'll share you today. One such technique is the linear programming, linear optimization. Okay, you might say, sir, we all know, we are the research scholars of a supply chain domain, we are the faculty, so we know it. I'll skip that, but I'm giving introduction only. So here you need three aspects. One is the decision variables, then objective, and then the constants. Objective means supply chain cost you want to minimize, or say service level you want to optimize. These are called objectives that you have to keep in your mind. For that, who are the decisions? How many containers will be there? What will be the inventory level? What will be the safety stock? These are called decision variables of supply chain. Then constants. So you might have number of constants in your system. It can be supply level constant, it can be manufacturing level constant, it can be container level constant, it can be route constraints. There will be many constants, service level constants. You have to address all of them because you have to optimize the integrated supply chain, right? It's not a one by one mapping of supply chain. It's an integrated supply chain. So in that case, you might have many constants, flow constants also. So once you capture all three aspects, decision variables, objective, what you have to do, you are planning to do, and the conditions, limitations, constants, you put together, then you can address a supply chain problem. In order to do that, there is a way called linear optimization, or linear programming problem, or integer programming problem, or a mixed integer programming problem. There are non-linearity can also come. We can use the non-linear programming also to solve the similar supply chain problem. But I am today going to show you simple linear optimization technique to solve a supply chain problem. This is the general structure of linear optimization. Here is the objective function. It could be supply chain cost, profit, service level, whatever you want, right? Risk minimization, so that you can maximize your return distribution planning. All these things can be a part of your supply chain or objective function. And then conditions, as I mentioned, there will be supply constraint, there will be money constraint, human resource constraint, route constraints, container constraints, service level constraints, anything can come. And these are all variables, that how many quantity you need to ship, in which route you need to ship, the route selection, the quantity selection, the container selection. It can be anything. You will get to know. It can be binary variable also. That means which plan to use, which plan not to use, that which warehouse to use. They might have many warehouses. You might not require to use all warehouses. So suppose you have a warehouse in, say, Srinagar domain, or say Himachal domain, but you can manage that distribution of that through your say Delhi warehouse. Okay, so Gurgaon warehouse. So you don't need to use that particular warehouse. You can rent it and you can use it for other purpose. So optimization includes the network planning also. That means the selection of warehouses, selection of supplier, along with selection of quantity and the container, etc. So all come under same root of optimization model structure. Then this is the basic structure. Now I'll show one application. Suppose this application, it might take time to read for you, but I'll explain that. It is a good distribution problem of a supply chain, very basic problem. But we all will understand how this concept so far we have understood can be applied for a supply chain distribution planning. It is a finished product problem, not the raw material. Raw material examples will be there in the next case. But here we'll understand how the modeling process can help here in designing a supply chain network. And then how can you optimize it? Entire thing can be done using this small example. So what is the problem? Let me explain that problem through this graph. So here all of this is called finished product distribution, right? Suppose the company has two manufacturing plant, production plant, say, as I mentioned, say example of say Maruti. So Maruti, say take the product of say single product, say take the product of Baleno. Okay, Maruti Baleno. So now they have two production plants. Say one is in Gurgaon, in Manesar plant Gurgaon, another say Surat, Sanant of Ahmedabad plant. Okay, so two plant. From there they will produce the product, and then these are the route. This is the distribution center. Say maybe in intermediate distribution center, maybe say Surat or maybe Jaipur somewhere distribution center is there, and one place maybe Delhi, one place maybe say Bombay. So these are the warehouse. So in this warehouse, the product has to be sent. Finished product. Here is the 60 demand, here is the 30 demand, here is the supply capacity of 50 Baleno, here is the supply capacity from Gujarat plant, say 40 Baleno. So this 40 plus 50 is 90. So it's a balance problem, say, and 30 and 60 is the 90. So this product has to be sent in each route. The amount of shipment of each Baleno is given. It is in dollar. You can think about the 900 rupees also per unit of Baleno shipment. So what is the best route? What is the best route so that you can distribute the goods with least cost? Will you send the product through this route? Will you send the product from this route? Will you send it from this route? from this route. So what is the best route? So that you can minimize your total distribution cost, supply chain cost. Here is the question. The decision is to make concern how much to ship through each shipping lane, so that your total shipping cost or supply chain cost is minimum. So this is the question. How will you address it? You may say that this is a small scale problem. I can use my mind and pen and paper and I can solve it. But that is not the objective of today's session. The objective is to create a generalized structure, so that a similar problem can also be solved using this structure. So we are going to formulate a general network design problem, so that this problem can also be solved. In any future, similar problem can also be designed under the same concept. So now what we will do, suppose from this particular plant, you have a 3 route. So in these 3 route, we'll send the product. We'll assume, suppose in this route, we'll send say X quantity. This route will send X2 quantity. In this route, we'll send say X3 quantity. So therefore, say X1 plus X2 plus X3, 3 quantity will send, couple of quantity we can send. So we'll assume like here, we can see quantity, this quantity, in which route how much quantity you want to ship. The decision variables we are defining. So here you have 1, 2, 3, 4, 5, 6, 7 route. So in each route, you can send say 7 quantity. Sorry, 7 routes are there. So 7 decision variables are required to send this 90 product. So here if you assume say X1 quantity, X2 quantity, X3 quantity, sum of X1 quantity, X2 quantity, X3 quantity should be less equals to 50, because 50 is the maximum distribution capacity. So this is the supply condition. What you have done, you have written X1 plus X2 plus X3. You don't know how much you are going to send. You don't do mind calculation. But the sum of these 3 should be less than 50. So actually you have developed this condition actually. This supply chain condition actually. Distribution condition from that particular node. Now, similar way you can develop for every, like here for DC. Inflow, these 2 route inflow, suppose say it is X2, suppose it is X4. So X2 plus X4 should be equals to X5, or maybe less equals to X5 or greater equals to X5, whatever you have. Here it will be balance problem, so it will be equal. So you will find a DC constants, intermediate constants. So that constant also you put in your system. This way you can define your conditions using the variables of how much quantity you are shifting. You don't know how much quantity you are shifting. System will, Excel solver, optimization techniques, model solution process will help you in getting the solution. You need to just design the structure only, network planning, optimization process only. And then what will be your objective function? Suppose in this route, if you send X quantity, then it will be 900 into X. If you send 1 quantity, 900 into 1. If you send 2 quantity, 900 into 2. So this way you can plan. Suppose you are shifting X3 quantity, so 900 into X3. So this way you can add all some product, 400 into X2. So 200 into X1. Here is a limit of 10. You cannot send more than 10 small tracks. You cannot send more than 10 baleno. So you can put that additional condition also. That in that route you cannot send more than 10. So this way you can create your objective function also. Some product of the cost and the corresponding quantity will be your objective function. Here is the structure. Look at this. Some product is the 249 is the 900 actually, 900 rupees per baleno. So for that particular route, in this route, if you send say X F1 W1 quantity as a notation, then total distribution cost on that route is 9 into number of baleno. But what will be the number of baleno, that software will, Excel solver can solve you, can help you in getting the solution. This optimization structure is being solved, is being developed using solver Excel in MS Office. Now MS Excel. Now this is your objective function. You can see the 7 route 1, 2, 3, 4, 5, 6, 7. Total objective function is this. Minimize the total distribution cost with the conditions, and two bound condition are there, bound like an upper bound condition in the 2 route, like here in this route and this route. If you put this in your, and the decision variable should be non-negative because it's a baleno, it cannot be negative. If you put that in solver or any if you do a code in MATLAB or any basic IBM simplex etc., within a second you will get a solution. Even in Excel also you may get a solution. Effectively, you got the solution in which route how much to shift and how much your total distribution cost. This is your network design. Actually, if you come back here, you can see the solution. In this route, first route you are not sending anything, then 40, then 10, and then 40. That means here 0, you are not sending anything on this route. In this route, you are shifting 40 quantity. Here you are shifting enter 40 from here. So total 40 plus 40, 80. And then here 60 you are meeting, then 20 you are shifting here. Here you are shifting 40. So 10 quantity. Here you are shifting 10 quantity, here 40 quantity. So 50 is gone, enter 40 is coming here. Done. Solution is ready. But effectively what you have solved, with least cost you have done. You have planned a distribution planning with the least cost. Look at this. You have managed a distribution planning, good distribution planning with the least cost. Now come back to a real life issue. So suppose Maruti, the Maruti chairman, Bhargava, etc., they don't understand this optimization process of supply chain. They know that I need to ship the product every day basis or every monthly basis or every quarter basis, week basis. So I need the best distribution planning based on my container size so that I can minimize my shipping cost, which we are solving it as a decision science colleague. So I believe everybody understood it. If you have a question, you can note down, we'll address later. Now, here you can see another example. Here you can see the more complicated example, more complicated network with the data. But will all these routes will be required or not? No. Here you can see the final solution. Only these routes will be required. Same concept we can apply. I'll share the PPT. We can try at home with this concept, how to be the decision variables. You can plan accordingly this way. And you can try solving this problem also. You can see the best route only. Not all route we are using. So this is called network design and the network planning, the optimal network planning with the least cost. So this is what, the basic concept of network optimization and application of optimization to solve a supply chain problem. Now you might say that, sir, these are all finished product. Is there any problem that you can share the entire end-to-end problem of supply chain? That means this structure, this type of structure, can you share like this type of structure where raw material will be there, supply chain will be there, plant, manufacturing plant will be there, distribution will be there, and the customer zone will be there. And more aspects will be taken into account, like design variable, the control variable, and the optimization process. Entire thing of supply chain network design, aspects of supply chain design will be there. Yes, I have brought that issue for you also with a real life case application. Let's see. Here, what are the things we'll cover? We'll focus that today. We are concentrating on the network design, right? This network design, as I mentioned, this type of application that I have shown you, or the structure that I have shown you, it is not only for the examples that are Maruti product that I have shown you. It can be applied to any particular domain. As I mentioned, for crude oil distribution, for raw material distribution, for train freight distribution planning, everywhere you can use for any product. Here I'll show you one milk distribution where you have the raw material, like the raw milk, finished product as a milk, packet milk like Amul, and then in the customer zone, if there a disruption happens, say demand is disruptive, route are not that okay. So in that case, there might be disruption in the route also. Cans or containers are some bit old, so refrigerator issue is there. So if all these things come into picture, then how you can optimize your distribution planning of the supply chain. The case is related to milk supply chain of a Chhattisgarh district. You might say that, sir, why you have taken milk distribution? This is a sample example illustration only. We can take many other examples as a case application to understand these aspects of the optimization and the network design aspects of supply chain optimization or supply chain management. So here we have taken the perishable product, we have taken the distribution issue, we have taken the network design issue, we have taken the uncertainty in the supply issue, we have taken the uncertainty in the demand issue. In each case inside our challenge, we have taken the uncertainty in the manufacturing plant also, we have taken the uncertainty in the distribution route also, because the company is facing these issues actually. And this case is not of the finance part of supply chain. This case is all about, to some extent, not the technological development in the implementation of supply chain, whether blockchain or data analytics or big data, etc., or IoT. We have not used that. It is a real case we have solved using the optimization technique. So we are going to see this, how it works actually. So here, why you have taken milk industry, that is a different part, but here I have put a slide because it is too much unorganized and it has not been focused by the government much, and it has a huge potential. India, one of the largest milk production in India, in the world after China. So you can see that we have a huge market of it based on the consumption and the export also. But we are not focusing much on that because it is to some extent unorganized. Small ownership are there. Not the government level, big level companies are giving. Even Amul is also not listed in stock market. So now, so what are the questions that we have addressed here? It is a perishable product and not a conventional product. So therefore, infrastructure and transportation is a big issue here. So this is the question, that how you can address this issue so that you can optimize the supply chain process. Second question is that, what is the best network for that particular case study, where you have the disruption in the route, disruption in the supply, disruption in the demand case. And what is your best quantity that you can match your demand supply in the customer level, because demand is different every day. So therefore, it is a milk product. It is not a monthly product or weekly product of like raw material, Maruti, Baleno, etc. Monthly product or weekly product company can calculate it from their retail store or the showroom, and then they can pass it to the manufacturing plant of Manesar or say Sanant of Gujarat. It is a different case. It is everyday demand is there. So you have to plan that demand and supply planning effectively. How we have done it, let's see. So this is the case actually. Here you will understand that it is a case of a Chhattisgarh district where I don't know to mention the name of the company. We have taken the data and we have discussed with them with the help of our team, and then we have addressed their issue. We have focused how you can improve the supply chain, you can minimize your cost if there is a disruption on the route and the other aspects of disruption that I have mentioned. So this is the 3-level echelon of the supply chain. Here you can see the manufacturing plant. Effectively, they have more than 5,000 cows. This case study was developed in 2018. So you can understand that by now they might have improved their technology and the distribution planning better. But this data we have from the in the middle of 2018. So this time they had around 5,000 cow, more than 5,000 cow. So they had actually 2 and buffaloes also. They had 2 production plant farm. In the morning 4 o'clock, before that they collect the raw milk from the farms, the production farms, and then they send that to 3 manufacturing plant in the city of Chhattisgarh district Raipur. Outskirts of the city, they have the manufacturing plant, and in that case, effectively, they have 3 plants, but they don't use all 3 plants actually. 2 plants are sufficient to meet the demand actually. 1 plant is a buffer plant, you can say, in some scenario they can use it, but effectively they use 2 plants. But there are many routes to send the product. There are many routes, like route 1, route 2. This because it's a 5 years, 6 years old case, you can understand that time the state was not improved in terms of transportation also. So therefore, they had too many issues in the transportation in the early morning because of road construction and the other traffic itself. So there are many routes, but in order to address this issue, we have taken the top 2 disruptive routes. In every case, we have taken top 2 disruptive routes. Here, in this case, we have taken only 1 route, the highest disruptive routes. You might ask, sir, how come you got the top 2 disruptive routes? They have provided the data to us. I'll show you the data. You will get to know in the forthcoming slides. So from each manufacturing plant or say raw production plant, farm to manufacturing plant, in the early morning before the product are being produced there and packet are being prepared to send to the retail zone. These are the 6 retail zone effectively. It is not a customer, it's a zone, retail zone to send the product in a bulk planning. So here you can see. So here we have taken 2 routes from each, 2 most disruptive route from each manufacturing warehouse, like a production plant, or say you can farm to manufacturing level, and the other routes are being given in the finished product shipment case. But here you can see they have a temperature issue, they have a old leakage and seepage issue, as well as the road infrastructure was not that good. So they are actually losing the product in this case also, in this echelon also, and here also, in this route also. They are losing the product and the product are getting wastage, etc. lost. So how they can improve it? So for that, they share the data of disruption. How much disruption are happening in each route tentatively. So you have taken the top 2 routes here and the top 1 route here, and then we have tried to optimize the best route so that total supply chain cost can be reduced. So that is the objective. Now for that, as I mentioned, we'll call the previous example that I have shown you, we'll call the optimization technique, the linear optimization technique. Here it is actually non-linear optimization technique, but I'll show you, I have explained the linear only. So based on that concept, we'll understand the case. So here, you have to design the structure. How you design the structure? If you come here, from here, you have a supply capacity, you have a manufacturing capacity, in the route also you have a capacity. Disruption is there everywhere because that is the main objective of this case. How you can optimize your network based on the disruption, and you should ship the product and meet the demand as much as possible with improving service level, and total cost should be also distribution cost, the supply chain cost should also be minimum. So that is the objective. So therefore, here from this particular echelon to this, so here how you can plan your total distribution cost. So in order to do that, we have developed, there will be one distribution cost, here will be one cost of product mismatch. If there is excess inventory, you will be losing the quantity. If there is excess too much of demand, you will lose the opportunity of getting profit. So how you can address this issue, these 3 issues? Let's see. This is the objective function or the structure, optimization structure. Let me keep all, we'll get to know. These are the decision variables. How many quantity you are shifting, in which route you are shifting actually. So this has been defined. So here, this is supply chain cost from supplier to manufacturing plant. Through route F, we have taken two route for each case, top to disruptive route. And then this is supplier means it's actually farm, your own farm. It's integrated supply chain. Okay, there is no third party. So here, your own farm, from that you are shifting the product actually. That means raw material, raw milk in the morning you have taken from the cow buffalo and you are shifting there to the manufacturing plant. So these are the decision variables. I'll share that, you will get to know the notation, etc. These are all like, unit production cost, unit distribution cost, shipping cost, and the quantity are being kept here. How much quantity you need to send, that system will decide it. So this is your total distribution cost between manufacturer, like raw material, raw milk to manufacturing plant in the early morning. This one, the second one, is the distribution cost of the finished product from here to retailer zone. How much total cost is coming out? All will be added here. Here also we have added one more thing. In case some manufacturing plant does not work and there is too much of demand comes, you can bring the raw material or finished product from some fictitious manufacturer or some third party, some local supplier. You can get that and you can meet that. So someday you could not produce sufficient amount of milk, suppose, and you have a good demand. Will you you will lose the opportunity? No. You can buy the raw material or milk from third party and you can meet the demand, and which can be processed in the manufacturing plant. So that opportunity, fictitious manufacturing opportunity is also there. Then these two cases are done. The last case, in the retail zone, what could be the issue? In the retail zone, effectively, if you have a excess inventory, because demand is uncertain, distribution variable, like say normal distribution is following, demand is uncertain, disruption is there, so demand is uncertain. In that case, and if you have route disruption also, in the route you have a disruption here and here, and demand is uncertain there, so you might meet the demand, you might not meet the demand every day. So therefore, if you meet the demand, you might have excess inventory of packet milk here, and which will be wasted. If there is a less demand in a particular zone, and if you send based on the previous day planning, if you send the product there, you might have, excess inventory. So there is also loss. So therefore, you have to find out a trade-off, the overstock and understock. That is called the use of news vendor structure under the supply chain network design when demand forecasting are not effective. So in that case, you can use that supplier cost, supply chain cost at the retailer level. So three components we add. Here you can see we have added the fixed charge cost, we have added the manufacturing level cost, we have added the supplier level cost, we have added the retailer level cost. Now all costs are being added. But here if you see this term, what is that? Here is the bracket started here, bracket ended here. What is that? This data are actually daily basis data. And this data, which plant to use, which manufacturing plant to use, this is actually to some extent, theoretically, these are, tactical decision, to some extent, stage one decision. So here, it is a quarterly basis. Every 3 months, we will decide which plant to use, etc., based on the demand of the particular season. So this is quarterly basis. These are binary variables, but this is daily basis decision making. Therefore, here we have multiplied this by 90. This is actually 90. So quarter. So this tau is nothing but 90. So therefore, it is a overall quarterly basis data are being developed. Structure has been developed. Then you put all the conditions like manufacturing capacity condition, supplier capacity condition, budget constraints, flow balance constraints, and then fill rate constant, service level constant, non-negativity constant, and the binary condition. Once you put all these things, it becomes an optimization model now. Your network is ready, but which network is the best, which route is the best, which manufacturing plant is the best, that is not been finalized yet. So that means network structure is ready, optimization model is ready, you need a solution. You can use IBM Cplex, you can use MATLAB, you can use solver, advanced level solver to solve it. Since there is a nonlinearity, we have this objective function is a nonlinear function because of stochastic demand parameter. We have converted into a linear structure using some approximation process. Let me skip this. And then we have found a basic linear structure after approximation. And then here we have used a simulation-based optimization model here. We have not used the direct optimization. We have, because it's a complex structure, so many variables are there. It took 6 months to solve this problem actually. So therefore, we used a simulation, Monte Carlo simulation-based optimization structure, where the genetic algorithm comes under the background of simulation optimization, and simulation will design the input of disruptive variables like supply disruption, route disruption. That is the main objective here, and then the main issue here. And demand uncertainty. So all things can be generated through simulation every time. In every iteration, you can see we have taken 1,000 iteration in every simulation. So every time all the disruptive parameters are being put with random distribution. Okay, and then we are taking through simulation for each variables, disruptive variables, one data, and we have run the optimization. Because then in that case, that system becomes deterministic model, and then you solve it. Then again, second iteration, you generate another disruptive parameters using simulation, and then again you solve the model. So all iterations we have kept, and then you have seen the histogram, and then you have seen which cost is the best, what is the minimum expected return, expected profit, all so cost, and all these things we have optimized. This simulation structure we have used to solve the optimization problem because there is a disruption. Simple linear like Excel, etc., or IBM C+ cannot handle that. So therefore, you need some advanced technique where you can take care of the uncertain parameters in the system also, and at the same time you can run the optimization process together. And then we have solved this using matrix modeling of a advanced Excel where simulation is being used under disruption to model the risk part of a supply chain. So here we have used 7.5%, now 8.6 is available. And these are the disruption we have taken: supply disruption, manufacturing plant disruption, and route disruption, including demand uncertainty in the echelon level, well, final customer level. And then we have taken the data. Here you can see this data to some extent scaled down, but based on the discussion of the organization and the actual their issues, we have taken care that this data actually, the per unit production cost, you can see the capacity of the manufacturing, supplier, farm level, fixed cost for three quarters, so like 3 months. And then this is the per unit processing cost per product, and all these things per liter, say. And then this way we can prepare our all data and look at the demand pattern also, tentative demand pattern in the different retailer zone in the city level, and with that variation also. They said demand are almost fixed actually. They are well known because they, based on their experience, they said the demand is almost, they know what could be the demand per day basis, etc., etc. So therefore, what we have taken very less variation there. The standard deviation is only 2 to 3%. But the main issue company is facing is actual disruption in the route. You can see, though we have taken only top 2 routes everywhere, but they are facing disruption. Look at the 5% disruption, 6% disruption. Here you can see the disruption level. Look at here. Sorry, these are the cost actually. This is the cost, transportation cost per quantity segment, say per in terms of liter. From here it is from the supplier to manufacturing plant, and from with route 1 and route 2, because you have taken only top 2 route, and from manufacturer to retail zone. So this is the distribution cost, but they have to minimize it. But the problem is here, this 3 table, here, these 2 table. Here you can see the disruption on an average 2% to 5%. You can see 5% disruption every day. Can you imagine this? That means if you send 100 liter, say to from manufacturer, say manufacturing plant, farmhouse to the manufacturing plant, 5% is been wasted every day. Can you imagine that? So they are losing the opportunity of cost or profit revenue. So they want to focus. So these are the kind of disruption amount. You can see 5%, 4%, 1%, etc. Top 2 route we have taken in each case. Though there are many more routes, top 2 we have taken based on this disruption data. And then we have used normal distribution here, everybody. For every route, we have used normal distribution with mean and 2-3% of disruption, standard deviation. Then we have designed the model using simulation and have optimized the process like the basic model that I have shown you using advanced Excel. Then we found 2 cases. One is the complete disruption case. If everywhere you have a disruption, supply disruption is there, route disruption is there, and the manufacturer demand uncertainty is there, then you can see your total cost is coming out to be 5 crore 67 in every quarter. 5 crore 67 based on the scale data, 5 crore 67 lakhs. But if you can reduce the disruption, if you convert the problem a disruption free supply chain, in that case you can see if there is no disruption, you can see your total supply chain cost for that quarter is 5, only supply chain cost. We have not taken any other aspects of the company, only disruption and the supply chain aspect, distribution aspects we have taken into consideration. And here you can see the total cost is coming out to be 5 crore 32 lakhs. So almost here you can say 35 lakhs you can save every quarter. Only on the disruption you can manage the disruption. So this is the actually findings that we have provided to the organization. That here you can see if you can trigger the particular route, that in this route this disruption is happening, and if you can replace the can, if you can see if there is a theft process is going on or not. So the people, those who are working on the organization, they might take away the milk every day, little bit amount. So that is happening or not. If there is a disruption in the route, the transportation issue is there in the route, So government can you can think about, government can think about improving the infrastructure of the road, which can save actually your cost, supply chain cost, along with your like seepage and leakage. All these things are being there, etc. So there we could see that if there is no disruption, and if there is a disruption, complete disruption, around 35 to 40 lakhs you can save in every quarter, only on this, considering these aspects, not all aspects of the organization. And here also we have seen that, to some extent, if there is all disruption, it is better to keep all manufacturing plant open. But if you take different cases, you might see only two, in general, only two manufacturing plant are sufficient, third plant are not required. But whenever all route are in uncertain, everything is uncertain, it is better to keep your third plant is also open. You might not use the entire capacity of the plant, but you use it so that you can minimize your supply chain cost. You might say that, sir, in that case, your products are maintenance cost of the manufacturing plant will increase. It might increase, but in terms of only focus only on the supply chain, the best is that all disruption case, all three plant you should utilize it. Otherwise, you can go with two cases only first two plant. That the findings we found actually. The data, based on this data, we found the quantity that you want to send each route. And also we found the total supply chain cost. Here you can see the mean demand, mean demand and the standard deviation, variation, everything has been mentioned here also. And also here you can see this slide I want to share with you. Here you can see, for the second last slide, here you can see that there are so many routes, right? If you come back to the graph, the figure, there are so many routes here you can see. Just a second. Here you can see so many routes. So around, here 15 routes, here it's 12 routes, 15 and 12 routes. So almost, 27 routes are there. But among these routes, who are the most disruptive? We found actually. Based on our analysis, we found who are the most disruptive routes that companies should trigger, so should concentrate. And if you see there, here you can see S2M1. S2M1 is the most disruptive route to the supply chain. So if company can trigger on that, whether some seepage or some pilferage are happening or not, something wrong is happening on this road, or this route is most disruptive, maybe because of construction issue of the road, or maybe deterioration of the road, etc. Or you can check the can is very old, what happening on that route. S1 supply 1, 2, that means farm level 2, S2 to manufacturing plant 1. That is the most disruptive. Second one, S2 to M1. You can see. So I'm not able to say. So here you can see the top 2, 3 disruptive. Let us see only one, S2 to M1. Maximum disruption is happening on that route. If company can take the top 10 we have listed here. So company should focus on this top 10 route. If they can save it, you can see they can save 42% of their supply chain actually. They can reduce 42% of supply chain they can reduce. In order to justify that whether this is the right result or not, you can see S2M1 route with F2 has the maximum disruption. S2M1, remember, and if you come back, the data, here you can see S2M1, S2M1, look at this here, this one, or F1 or F2 for us, both have a maximum 5% disruption is happening here. So company says, our model says that this route is the most disruptive route with 5% disruption. So you should concentrate there, which will reduce your supply chain cost drastically, because that route is not only the route, it has an implication in the succeeding routes also. So concentrate on that route. So this way we have listed top 10 route where company can focus, and they can save up to 40% of disruption actually, the supply chain cost also they can save. There are many more findings we found, but I have shared only a couple of them only in this particular analysis, which is called tornado graph analysis. And then also we have seen scatter plot also, how it is the data are being distributed here. And then there are many more findings we found for this particular case application as application of supply chain network design and optimization. But this is only one case illustration how you can design a supply chain and how you can optimize it using some optimization technique. Here I have not focused on the optimization technique of simulation, Monte Carlo simulation, or the base of supply chain optimization, etc. Integer program, binary integer programming, but we have used it mixed integer programming using binary variables as well as simulation also. But I have shown you the basic supply chain of linear optimization. Same concept, linear optimization I have shown you today. But here you can use some variables as a mixed integer, some variable you can consider as a binary variable, some etc. other thing you can also consider. Non-linearity can also be considered. Optimization can be done using genetic algorithm or some PSG algorithm, or maybe some simulation structure also. Or you can design your code using any particular software. Here I have shown you simulation-based optimization technique to use it, and we have solved a case. Now, what we have covered, since I have a limited time is almost over. What we have captured here, the modeling process of optimization of supply chain we have taken. Network design, how to do a network design, we have tried to understand that basic problem and the case application, and how we can optimize it, because without doing third step, you cannot get a solution of the best network. So you need optimization. The optimization also we have tried to discuss how optimization can be done. And then if there is a disruption in the system, then how can you optimize your network? So the disruption also taken into consideration, and the optimization has been done using a simulation-based solution process. And we have seen the entire process, all these 4 or 5 aspects, using a case application called milk supply chain. These are the only aspects that we have captured in this particular session. There are many more aspects which you can take into account, but with the limited time, I thought of capturing only the basic level of network optimization and the design process also using a case application. So with that, I will conclude my session. If there is a question, I can then address.
Thank you very much, sir, for the wonderful session, which was very informative, even for people who are not from the supply chain background. I think we could understand it very clearly. Thank you for explaining it very nicely with the proper case study. We'll take up a few questions. If audience are having any questions, please ask, or even you can put in the chat box. Please let us know if you have any questions.
Hello, sir.
Yes,
One question in my side.
Yes, please.
If want to, यदि ज़्यादा दूर है ना, more distance of the other manufacturing plant, and which plant is consume the product, so what is the criteria? क्योंकि क्या होता है कि जैसे HUL है, हिंदुस्तान यूनिलीवर लिमिटेड है, और ये क्या कर रहे हैं कि कुछ प्रोडक्ट ऐसे हैं जो इंडिया में नहीं बनते हैं और फॉरेन से इनको मंगाने पड़ते हैं, तो उसमें काफी कॉस्ट इनकी ट्रेवल की ही लग जाती है, प्रोडक्ट की कॉस्टिंग काफी कम रहती है, और इनके जो प्रोडक्ट होते हैं वो भी काफी कम, FMCG है तो काफी सस्ते होते हैं.
Yes. Okay, I understood your point. You are talking that if time is not considered, if there is a long distance, then how to take care of the issues, right?
Yes.
Suppose let me explain that. Let me explain your problem. If I understood effectively, I can explain that through the diagram itself. You will get to know the concept here. Here, if you see this, is the screen is visible to you?
Yes, I visual.
So here you can see, suppose here is the one route. Suppose here is one route. Okay, from here plant, manufacturing plant, or say warehouse to say retail zone, or say suppose it is from Bombay to Delhi, or say Bombay to Calcutta. Both are not from Bombay to say Jaipur and Bombay to say Calcutta. Both are not the same distance, or say Northeast, not the same distance. So how you consider time? We have not taken this as a limitation. We have not considered time in our model. That's a limitation. But how we have addressed that issue? If in this particular route, we know the total cost, right? So there we have divided it by quantity, the total cost by quantity. Overall, we found the cost per unit. So that cost, if this is a Jaipur and this is a Calcutta, so from Bombay manufacturing hub to say Jaipur, the total cost will be less, because we have not taken time, but we know what will be the cost because it's a closure. So overall total quantity based on the past data, we realize that per unit quantity how much is the cost. That we have put in the data.
Yes.
But you can take time wise also, time and the distance. Then it will be more complicated model. But here we have adjusted that based on the past data.
Yes, sir.
Any other question?
Sir, one more question in my side.
Yes, please.
ये कई बार क्या होता है, टाटा स्टील से है, यहाँ पर सप्लाई करना होता है इसका कच्चे लोहे का, तो हम कई बार टाटा से जब छत्तीसगढ़ भेजते हैं, कई बार इधर से भेजते हैं, और रूट में क्या है कि काफी ज्यादा ट्रैफिक होता है और टाइम लग जाता है और चेकिंग वगैरह के लिए, तो इनके लिए कोई और ऑप्शंस हो सकते हैं क्या?
Yes, let me tell you. Even to be honest, in India, most of the people have focused the basic supply chain.
Yes, yes.
They are these days actually freight transportation are coming into the picture of research, and those who are working on freight transportation and the optimization process there, even they are quickly publishing their research paper actually. So freight transportation is the best option to ship this type of huge amount of raw material from say Chhattisgarh district or say Tatanagar to different location actually.
Yes, yes.
So it is better to use freight distribution rather than simple truck to ship the raw material there.
Yes.
And government is working on that, focusing on that particular huge level of raw materials demand, specifically coals and other mines through, or maybe vegetables also through freight transportation. Companies, industry, the government is focusing too much on that also. That is the best way to manage actually.
Yes, yes. Many mines is nearby in the Tata
Yes.
Steel.
So better
Okay,
to
thank
use
you.
freight transportation there, but in terms of rail than road.
Yes, yes. Thank you so much, sir. Thank you so much.
Thank you very much, sir, for once again for accepting our invite and delivering such a wonderful lecture for us. We really appreciate your kind gesture, sir.
Thank you,
Uh,
thank you.
thank, thank you once again. So, on behalf of IIITS VCT and the organizers, I express our sincere thanks. Thank you, sir. Thank you. Good evening, all. So we'll again go with the next session. We have with us Professor Usha Mohan from IIT Madras. Thank you very much, ma'am, for being with us, for accepting our invite. It's actually an honor to have you with us, and we are really eager in listening to you. Thank you for, and sorry for keeping you waiting for some time. It's really a great pleasure to have you here. So I'll briefly introduce you, ma'am, and then you can go ahead. Ma'am is a professor at the Department of Management Studies at IIT Madras. She has completed her PhD from Indian Statistical Institute in the year 2002. Her area of interest varies from quantitative models in supply chain management, optimization, mathematical programming, etc. So she's a well-known expert in this field. Thanks again, ma'am, for joining us. So we are very eager to hear from you. And thanks again, ma'am. Thank you. Over to you, ma'am.
Yeah, thank you, Dr. Arun, and good evening, everybody. Am I audible? Is it clear?
Yes, ma'am, you are audible. Yes.
Okay, thank you. Good evening, everybody. And it's a pleasure to be here and share some of my thoughts on the topic, the role of technology in supply chain. So mine is not going to be theoretical. I'm not going to present with any models or anything. Considering the time of the day, it is already past 5 p.m. So I'll just take you all through what is the technological changes that are happening in the supply chain worldwide, especially global supply chain, and how these things have been very important with the advent of COVID. I think most of my talk would have a few videos, so that I hope that should be possible to play videos on this platform, right, Dr. Arun? Okay, so I'll just share my screen. Is my slide visible, please? Are you able to see my slides?
Yes, ma'am, we can see the slides. Yes, ma'am.
Okay, right. Yeah, thank you. So what we are going to do in the next 1 hour is to understand what is the role of technology in supply chain. And towards this, I would like to make it as interactive as possible. So let me try and open the chat box so that we can have a chat going on. Just give me a minute. So you can please use the chat box. I would like you all to please interact as much as possible. 1 second. Yeah. So I hope this is visible. Yeah. Okay. So now the whole idea of this talk is to introduce and to show you all what is happening with respect to technology in supply chains. And the main idea is to understand that over the past few decades, what is happening is there has been a lot of development that is happening with what is called as internet or Internet of Things. On one side, you have robotics playing a big role. On the other side, you have advanced analytics, artificial intelligence, and machine learning coming together. And we would like to understand that what is the whole, how are things in the supply chain domain changing because of that. So one thing which I want to just show you all is the following, is I'll just share one picture and I'll take it forward from there. So let me stop presenting this and share one particular picture. So when we talk about supply chains, is this picture visible? Is it good enough, or do you want me to zoom it up a bit?
Is it visible, ma'am?
It's visible. Okay. So what is, when we talk about a traditional supply chain, okay, what you can see on one part of your slide is what is a traditional supply chain. It has typically a supplier, it has a producer, distributor, retailer, and the end customer. And this has a physical product flow, it has information flow, and this is any 101 class or in the first class of supply chain, this is what you learn is, okay, this is how a traditional supply chain is structured or designed. What are the problems with the supply chain? There are a lot of inefficiencies in the supply chain. There is limited visibility throughout the supply chain. There is lack of real-time data after this one. It is not responsive to changing market conditions, and there are inherent delays in the supply chain. Now, what is the need of the hour? The need of the hour is, instead of having this, is there a way I can reduce this inefficiency? Can I, instead of what I mean by limited visibility throughout the supply chain, can I increase the visibility and make my supply chain more transparent? Can it again adapt and be more responsive? Can I make it more agile? So when I have these questions asked, I move from a traditional supply chain to a digital supply chain ecosystem. So when we move from a traditional to a digital supply chain ecosystem, I'm talking about control towers, I'm talking about digital twins, I'm talking about tracing and tracking, and I'm talking about a lot of technologies that would enable this digital twin or digital supply chain system. So most of my talk is going to be focused on how we come up with this digital system. Okay. So let me start by asking you all a question as to what do you understand by Industry 4.0? I want it to be interactive, so I want you all to respond. You may unmute yourself and talk. What is it that you understand by Industry 4.0? Anyone? What is it when we mention Industry 4.0? What is it that we mean by Industry 4.0? Yes, anyone? Have you all heard the term Industry 4.0 or 4.0? What is it that we understand by Industry 4.0? I'm unable to see the chat window. Okay, what is Industry 4.0? Anyone? You may use the chat box also. So why do I need to talk about Industry 4.0 is, I want to, as I said, my purpose is to improve my supply chain, which is traditional supply chain. When I talk about my traditional supply chain has a lot of inefficiencies, and I want to improve the supply chain, and I want to see how the supply chain management has been significantly impacted by technology. So when I go to Industry 4.0, we say that the four industrial revolutions. The first industrial revolution was when we talked about mechanization. The second was what we call the mass production, and here the automobile industry, where we had the assembly line, the electricity, and all of that was in the second industrial, this one. The third industrial revolution focused on computer and automation. And the fourth industrial revolution, which is what we refer to as Industry 4.0, is where we have the cyber physical system, and here the Internet of Things play a very, very crucial role. So this is Industry 4.0 is all about data, capturing data, and how are we going to use this data to enhance the end-to-end visibility in a supply chain. So when we Derek Foster et al., when he proposed the technology pillars, what are the key technology pillars of Industry 4.0? He talks about autonomous robots, digital twin simulation. I'm just going to mark a few things which are going to be very relevant with respect to supply chain: industrial internet or sensors, cyber security, cloud, additive manufacturing, augmented or mixed reality, big data and analytics. So you see that when we autonomous robots also, when we are talking about the technology pillars of Industry 4.0, immediately we see that all these pillars have a major role to play when we talk about supply chain or moving from traditional supply chains to digital supply chains. So the next thing is we want to, since Industry 4.0 has created a disruption, this Industry 4.0 and technology enablers or technology pillars of Industry 4.0 have required companies to rethink the way they design their supply chain. So what happens is supply chains, they have the opportunity to actually reach the next level of operational effectiveness and focus on emerging digital business chain models. So the whole idea, the way McKinsey has actually defined or presented the supply chain 4.0, is the application of Internet of Things, which is also referred to as IoT, advanced robotics, the application of advanced analytics of big data, and place sensors everywhere, create networks everywhere, automate everything, and analyze everything to significantly improve performance and customer satisfaction. So you can see the infographic which sort of projects what is a supply chain 4.0. You have a customer care. Here a customer can receive route shipment via mobile phone. Then when you look at a warehouse, the warehouse has an automated warehouse where the robots are actually doing the picking and transporting. You have what is called predictive shipping. You have an autonomous truck here. And then after you have integrated and ad hoc mobile planning. And within here, you also have automatic reconfiguring of network. You have drone delivery here. And finally, you have this forecasting where advanced predictive analytics is going to play a very big role, leading to end-to-end performance management. So let's look at a few things as to how it is actually done. So you can see here two things. One is predictive shipping and another is autonomous truck. Now, when the Association of Supply Chain Management has listed these as the top 10 trends of supply chain management in 2023. Again, you can see the digital supply chain, the artificial intelligence and machine learning, robotics, data security, cyber security, smart logistics and Internet of Things, big data and analytics. All of them are again key trends. So out of the 10 trends, you see 6 of these trends are actually directly related to technology or digital supply chains. So now let's go and here look at what is predictive shipping. Anybody can guess what is predictive shipping, please? Any guesses? What do you understand by predictive shipping? By technology, I'm not only restricting myself to technology, we also have big data analytics playing a huge role. So what do you think is predictive shipping or anticipatory shipping? Any idea? Okay, what predictive shipping is Amazon made headlines very recently for an anticipatory shipping model where it says that I will box and ship products it expects customers in a specific area would want. This is very important. So what Amazon actually is doing is it is predicting what users would like to buy, when they would want to buy, and where they would need it. How is it predicting? It is predicting based on customer data. So this is one of the best use of predictive analytics, where it is using predictive analytics to do a predictive shipping by actually shipping products to places where it expects, or based on an expectation or based on what a customer in a specific area will want based on previous orders. It is predicting, and it is always doing a predictive shipping. So what happens because of this? Packages could wait at shippers hub or trucks, but the customer's orders are satisfied much earlier. The next thing is we are talking about here is drone delivery using drone delivery and autonomous trucks. Now, drone delivery and autonomous trucks, Amazon Prime again has patent on what is the first customer delivery. I would be sharing my slides. I don't think I have the time to just display all the videos I have here, but I'll just show you one of the videos perhaps. One is the autonomous truck, where there is a self-driving truck. Are you all able to see my screen, or not able to see the screen? Are you all able to see the truck, the screen?
Hello, ma'am.
Yeah.
Yes, it's visible, ma'am. Now. Yeah.
Are you able to see the screen now? There's a YouTube video.
Yes, ma'am.
Are you able to see it?
Visible. Yeah. Yes,
So
ma'am.
now what this video talks about is the following. It's basically this company Auto, which was obtained by Uber. And this, where you can see it's a self-driving truck. And this self-driving truck makes its first delivery. And this delivery was of, this shows that how the self-driving or autonomous vehicles were used. This was actually a pilot study, and how this was actually used for the delivery in a particular. So you can see that this made actually 50,000 beers and spent 2 hours driving itself on a Colorado highway. So you can see that this is a very, very important thing when you're talking about supply chain technology, because delivery is a very, very important thing of supply chain. Now, when we look at artificial intelligence based supply chain, again, there are a lot of supply chain solutions which are based on artificial intelligence. All company functions, right from sales to procurement, it actually addresses and limits with an integrated end-to-end approach. One common theme of this entire presentation is the fact that we are seeking end-to-end. We are seeking solutions end-to-end. We are talking about end-to-end visibility. How good or how transparent can I make my supply chain? Because this artificial technology and this technology driven evolution to Industry 5.0, this involves a more collaborative approach and partnership between humans and robots. So when we talk about robots, there are a lot of things which are actually used. Again, if I go back to my 9 pillars, I saw cyber security to be an important pillar. When I talk about cyber security, something that comes to my mind immediately is blockchain. What is a blockchain technology, and how is blockchain technology actually influencing supply chains? With blockchain, what is happening is supply chains are able to document production updates in a single shared ledger. Blockchain is nothing but a shared ledger, and this improves the entire visibility and a single source of truth. So when you have a blockchain, you're actually enabling supply chain transparency across the supply chain. Hence, you're enhancing what is called end-to-end visibility. The second thing that can happen with blockchain technology is the transactions in a blockchain are time stamped. So whenever a company can query a product status, you cannot have any person or any entity or any player within the supply chain who can damage the data. Since this is a shared ledger, the time stamped and up to date companies can query a product status and location at any point of time. It also ensures that quality standards are met, giving the seller more control of the production of the product. So blockchain is an extremely important technology. One of the companies that have pioneered in the blockchain technology is IBM. IBM with Maersk, which is a container transport, have actually, in this case study, IBM and Maersk actually show as to how blockchain technology is. Is the audio audible of the video?
It is not audible. We can just see it's not audible.
Point communication.
Is it audible?
Yeah, now it's audible. Now it's audible.
Transportation providers, freight forwarders, customs brokers, governments, ports, and ocean carriers. IBM and Maersk are addressing this problem with a distributed, permission platform accessible by the supply chain ecosystem designed to exchange event data and handle document workflows. Maersk and IBM are employing blockchain technology to create a global tamper-proof system for digitizing trade workflow and tracking shipments end-to-end. Eliminate.
So the purpose of this case study is again to see that IBM and Maersk together have created a blockchain platform to actually come up with a tamper-proof platform. That is what the case study says. Okay. Now the next case study is what is called additive technology. Additive technology is also referred to as a 3D technology. Now, any idea as to how 3D printing is changing the supply chain? And why do we think that this technology is important from a supply chain perspective? Additive technology or 3D printing. One of the companies again which have pioneered in this 3D printing are actually the companies of Germany, where you can see the following is this company, where you can see that this company, I'll just show you a glimpse of it, where they are making all these parts.
Müssen wir häufig 10, 15, 20, zum Teil sogar 100 Teile abnehmen. Und da bietet die additive Fertigung natürlich eine riesige Chance. Einmal, dass wir uns dieses Teil gar nicht auf Lager legen müssen, aber auch die Vermeidung dieser Überproduktion. Mit EOS haben wir einen sehr guten Partner an der Hand, der in den unterschiedlichsten Feldern schon.
So what you can see is 3D printing and additive technology or additive manufacturing. One of the main things is with 3D printing, you don't have to hold inventory. This was asked by one of the participants in the earlier thing is, what do we do when I have to import a lot of products or import a lot of raw material or spare parts from which are not manufactured in India? So if you have a 3D printing and additive manufacturing technology, then afterwards you don't have to keep this stock of these products. You can have, and 3D printing is actually changing the entire supply chain, especially when you have to manufacture these small spare parts. Now the next important technology which is actually playing a very, very huge role is the Internet of Things. Now when we talk about Internet of Things, it's basically I am tracking and tracing assets. That is one of the main things. What is happening in these days is we see that everywhere we have sensors. When you walk, all of us know the smart watch. How many of us use a smartwatch? When we use a smartwatch, we know the smartwatch is tracking how much we walk, how long we sleep, what is the what is my heart rate when I walk, how much water I am drinking, what is it I'm eating. Everything is being tracked based on the smartwatch. Now, if a smartwatch can track so much, imagine if I had a smart container. What is a smart container? So imagine what could happen if I had a smart container. So you can look at this, that this is a smart container, And what is a smart container? A smart
Cargo.
container.
No one person has total visibility of the whole trip, and you and your providers can spend a lot of time and money chasing information. Delays and accidents happen, and you may not find out until it's too late to recover. Lack of visibility means uncertainty. Uncertainty means keeping more inventory. More inventory means cost. But there is a better way. You can now choose to move your goods in a smart container. A smart container is a dumb container with an added electronics from Traxons. A smart container knows a lot. When it's cold and when it's hot. When it's on time and when it's not. If the doors have been opened unexpectedly. Where it's from, where it is, and where it's going. And if there is a bump, it knows when and where. And it can send all this and more to Trax Hub in the cloud, so that you have all the information you need from a single source. And you don't need to spend your time checking. Because the smart container can alert you when something important happens. But that's not all, there is more. You can choose to channel information directly to the right people to get the best performance within your organization, and directly to your provider so that they can increase coordination and drive down their costs. And with shorter transit times and real-time warning of disruption, you can control your inventory like never before. But that's not all, there is more. All the information from your stock in transit can be directly sent to your information systems, which means that when accidents happen, the impact on your operations is known in real time, and contingency plans can be triggered.
So you can see that if I have such a smart container which is tracking all my data, and this data is going to the cloud, and from the cloud I have access, you can see that I can react. So we wanted more responsiveness. I can respond to disruptions much faster, and I can react to a lot of my demand changes much faster. So I may keep much lesser inventory. Now, when I keep much lesser inventory, it reduces my cost. And this is the alerts and navigation help me plan in a very, very seamless way. So you can see how these tracks have actually helped a lot of things. Now the next is what is called as control towers. Any idea what is a supply chain control tower? Have you all heard of this? A supply chain control tower, let's understand this again through an animation as to what is a supply chain control tower. This is from Agility
What is a
Logistics.
supply chain control tower? Global supply chains are extremely complex. Working with multiple third-party logistics providers can adversely affect supply chain visibility, leaving companies struggling to gather the necessary data to resolve exceptions, take corrective actions, improve processes, and manage costs. The technology of a supply chain control tower offers companies the ability to gather and evaluate real-time data throughout the entire global supply chain. A supply chain control tower isn't necessarily a physical tower or object. Think of it as a centralized hub containing all the technology, organization tools, and processes needed to capture data from all stages of the supply chain, from the manufacturer to the final customer. Businesses can benefit from a supply chain control tower because it provides end-to-end supply chain visibility to all stakeholders, minimizes supply chain risk, costs, and exceptions, encourages collaboration throughout the chain, responds to and resolves supply chain disruptions in real time, uses predictive data for more accurate forecasting and decision-making, tracks shipment location and delivery time estimates, provides accurate management information in a single place, allowing decisions to be fact-based and data-driven. The control tower uses real-time data to identify strengths and weaknesses within the supply chain, using predictive analytics to guide the network toward greater efficiency and improved processes. A supply chain control tower is powered by technology and driven by people. It can instantly aggregate data from inventory, production and warehousing centers to guide improvements and mitigate exceptions with great efficiency. For more information, visit.
So this supply chain control tower, I'm sorry, there was a drop. I really apologize for that.
No problem, ma'am. No problem.
Sorry. Yeah. So now let me go back and show you my screen. Okay. I thought it would be a Zoom call, so I think Meet, I'm not very comfortable with that. But anyway, I hope it's not doing too badly with it. So supply chain control towers is basically a very well connected personalized dashboard of data. So you can you can imagine like this air traffic control, which is a control tower, and that is what is controlling the flights that are landing, flights that are taking off, and everything. What this tracks is basically all the data that goes to the cloud. It tracks the key business metrics and events across the supply chain. Now, this supply chain control tower actually enables organizations to fully understand, prioritize, and resolve critical issues. Now, all of us know that there was a very recent Suez Canal blockade. All of us know about it. Have you heard about the Suez Canal blockade? Yeah. Now, what was the impact of the Suez Canal blockade on supply chains? What do you think would have been the impact of the Suez Canal blockade on the supply chains? Anyone, please? You see that what happened in the Suez Canal blockade was I had a ship which was actually blocked the canal, and as a result of which a lot of trade got, because Suez Canal is one of the most important trade route in the world, a lot of containers got stuck. Now, when such a thing happens, if you are having a supply chain control tower and you are able to visualize your entire end-to-end visibility, you can take immediate action as to, okay, if my ship is stuck at a particular level, is there a possibility for me to take at least part of the order and ship part of the order by any other mode of transport? Or can I actually in real time tell to my customers that this is the delay they can expect, rather than keeping on telling them and dynamically changing my entire delay time? Associated with supply chain control tower, another important technology which is playing a major role in current day supply chains is the concept of a digital twin. A digital twin is basically a digital replica of a physical supply chain. Now, what is a digital twin and why does it help us? See, all of us understand simulation as a tool. Simulation as a tool basically helps us simulate a real-time process. But what a digital twin does is it is a complete digital replica of the physical supply chain, right from your raw material suppliers to your warehouse, to your manufacturers, to your warehouse, to your retailer, to your customer. The entire product flow is simulated in the digital twin. Now, what happens to organizations because of this digital twin is it recreates the entire supply chain in a virtual world. Once it recreates the entire supply chain in a virtual world, what it does is simulate scenarios. It creates test scenarios. It models different modes. It understands how I should look at disruptions. If a disruption has happened, what is going to be my impact on my entire operations? And when we are talking about operations, we are not talking about just straightforward operation. We are talking about a very, very complex network of operations. So you can see that this digital twin, it also helps in improving end-to-end visibility. Not only that, it's a very good planning tool. It will help me plan how decisions and disruptions will impact my network operations. So the case study I have here for you is to see Henkel. Henkel is a very popular German detergent plant, and how the digital twin has worked in this case.
Hello, it's me, your laundry bottle. In this episode, we will unleash how our digital technologies have changed my life. Let's have a look. Henkel is creating an end-to-end digital twin of our supply chain, which is fully transparent, agile, and data-driven. Here, algorithms sense the demand and immediately adjust the supply network and replenish what is needed to replicate me. When my friends and I arrive at our facility, we get shaped, filled, sealed, dressed up for the big photo shoot, and are constantly monitored by cutting-edge.
So this is the key point. You can see that what is happening here is till this point where we were filling it up, it is a physical supply chain. And at this point, you can see that there are a lot of sensors, and all these sensors are actually capturing that data that is on this bottle of detergent. Now, what is the kind of data that is being serviced?
No single attribute is left to chance. I was very excited when Henkel decided to give me a new tattoo, which you can now scan to learn everything about me and my life cycle.
So you can see the entire product life cycle is captured in a barcode, and this barcode will tell about everything about this product, including the quality attributes. And this quality attributes helps us detect whether a bad product is there at a much earlier stage itself.
The coolest part is when I move on automated vehicles who know where to go after picking me up. My creators base their decision on data being available globally, powered by algorithms and IoT devices. This rapid digital transformation has given Henkel a competitive edge through innovation and a future-ready operating model. In the key areas of laundry and home care supply chain, digitalization enabled significant improvements in service, cost, cash, and agility, all while exceeding world-class sustainability targets since 2005. Since we have started our path on digital transformation, we have enhanced supply chain resilience and readiness for future challenges. Digitalization is allowing us to focus on our priorities, the best product, and creating value for our customers and consumers.
So you can see that this digital twin has helped in actually reducing costs in a supply chain, and then afterwards it has also increased agility in a supply chain. The way they have done it is through creating what is called a digital replica of the physical supply chain. So the digital twin technology is a very, very popular technology. A lot of companies, including pharma companies, manufacturing companies, are investing heavily in digital technology. One of the things which I wanted to mention earlier itself is the importance of technology in supply chain sees itself even in companies. Nowadays, you have a chief technology officer, and now you have a CXO role as a chief supply chain officer also, where the supply chain officer is no longer related, or it is not relegated only to a service role or a person who is delivering what the operations need, but it is also creating, it is aligned with the entire strategy of the supply chain. The last technology I want to talk about today is that of robotics. Now, robotics is, again, it has been there for a long time, but how is this being used in supply chain? What robotics does is it allows supply chains to actually scale up faster and meet supply requirements as demand increases. Especially when we are talking about large scale demand and we are talking about satisfying the large scale demand, the robotics actually allows for greater workforce adaptability, improving safety of workers, and actually it also takes charge of retrieving a lot of items from high storage places. So in warehouse management, and warehouse management system is again a very important portion of supply chain, we see robotics plays a very, very key role. One of the case studies I have for you today is on Ocado grocery warehouse and how robotics has helped the warehouse. So you can see here the robots are actually packing grocery orders. Now, even though they move along the grid system, their sensors allow them not to control. So what they are controlled is by an air traffic control system. And because they are controlled by an air traffic control system, you can see that they do not have any collisions. And the technology they again use to communicate between one another is a 4G communication technology. So you don't see the robots crashing into one another. And this you can see is a massive warehouse where you have a top speed of about 4 meters per second, and all the orders are being collected by the robots. Robots are again battery operated here, and you can see the amount of orders, which is close to 65,000 orders per week, which is being satisfied. And what is being used here is the one thing is here, this is a grocery supply chain. Hence, the grocery supply chain, the perishability is of great concern in a grocery supply chain. And we can see that how this robots are helping satisfy the grocery orders. So now you can see exactly how the crates are being taken by the robots. The barcode readers are actually looking at reading the barcode. Readers are reading the barcode on the products, and the products are being created. They are replaced in an empty grid. So you can see that how the entire system is working. Ocado is one of the pioneers in having automated warehouses. So what we have seen so far is how, so that is about Ocado and how Ocado has actually used automated warehouses to actually improve their supply chain efficiencies. So now going back to where we started by looking at what is the role of technology in supply chains. And we also saw that when I talk about the technology pillars, these are the technological pillars. So I saw a case of autonomous robots, and this was the case study of Ocado, where we showed that the autonomous robots can help you in automated warehouses. We looked at digital twins, and digital twins, how the Henkel laundry detergent has helped us in digital twins. How sensors, so here we saw how the RFID sensors and how the sensors have been used in smart container ship, how this is smart containers, that is where we saw these sensors. When we talked about cyber security, we talked about the blockchain and how the blockchain has actually used, how IBM and Maersk, how the ledgers and how it uses and actually produces tamper-proof transactions. And another thing with blockchain is it results in what we call as smart contracts. Again, all of this is, again, we saw how things that the data is transferred to a cloud, and from the cloud, how again data is retrieved and how you can maintain end-to-end visibility. We looked at additive manufacturing or 3D printing. In this case, again, we saw that how German companies have actually exploited 3D printing and additive manufacturing to reduce their inventory levels. Once you reduce your inventory levels, your supply chain costs come down automatically. Now, all these things are generating a lot of data. And that's where you need the big data and analytics. In fact, I would say that all this data that is being generated is something that has to be used properly. We also saw how Amazon uses this very effectively. And that is the case where we talked about predictive shipping or anticipatory shipping. By using a consumer's point of sale data, how they use that data effectively to try and ship expected products so that the consumer does not have to wait. So this is about supply chain 4.0 and the technologies that are in supply chain 4.0. I gave a few examples, and this is how you can see that supply chain 4.0, the main thing is how these digital supply chains actually help in increasing the end-to-end visibility in a supply chain. The last thing which I want to show is this IBM Maersk data thing, which I did not show. I think we have a couple of minutes. No, I think I showed this also, but yeah, there was another thing which I wanted to show. I think I'll just, yeah. So this is about the supply chain technologies. I just focused on the current technologies. I did not talk about, because these are not mentioned in most of the textbooks. Most of the textbooks restrict themselves to what they restrict themselves to is role of information technology in the supply chain. And again, there they just talk about enterprise resource systems, and they talk about electronic data interchange. They talk about RFIDs. But then afterwards, in the last few years, in fact, the last couple of years, there has been a boom, and the pandemic has also resulted in us going for other new technologies and how to enhance supply chains using other technologies, mainly artificial intelligence, machine learning algorithms, and how the data that is captured is used effectively to bring down inefficiencies in supply chain and reduce the cost and hence improve the profits. So I'm open for questions. I planned 10 minutes for Q&A. So please go ahead and ask me any questions that you could have. I'll answer to the best of my abilities.
Thank you very much, ma'am, for the very intuitive and very interesting presentation. Really, I enjoyed it. I mean, with videos and, without much mathematical stuffs, it was really,
I hope I did not, because there's nothing mathematical here. I just wanted to give a broad overview of the available current technologies in supply chain and how supply chains are actually improving because of that.
Yes, ma'am. So it was really, really interesting. Like, it was, I mean, for beginners like us, it was really, really interesting. So, participants, please, this is a very good opportunity to interact with ma'am. So please ask your queries.
Yeah, please. Any questions you can ask me. I'll try and answer it to the best of my capabilities.
Thank you, Krishnakant, for the comment. If you have any queries, please ask.
And it can be on anything on supply chain. It need not be on what technology only on supply chain. You can ask what is the current state of art also, and I'll try to answer to the best of my abilities. You can see that one comment was in India, particularly in India, we are, except for a few supply chains like the automotive supply chains or the pharmaceutical supply chains, we are very, very immature, or we are not that organized in other supply chain. One supply chain where we lack a lot is in the food supply chain. In fact, that is where blockchains or RFIDs can help us a lot. Is as a consumer, we do not know much about the food that we are eating, right from perishables. It's only now that there are a few packaged goods which have barcodes, and from the barcodes we can know about the date of packaging and we can trace the food to actually its source. But that is very important, and it's not a very even though blockchain could be not a very immediate technology, but RFID and barcodes can be definitely used in the perishable industry. And as consumers, if people use these barcodes, then afterwards it would be very helpful as a consumer. You'll actually know where you're eating. And one place where it could also help us is nowadays a lot of people, they claim to be organic food, where we really do not know whether it is organic food. And if I can trace the source, it would help me to understand whether it is organic or not. I think there is a question is, will 5G be a boon or bane? I'm sorry, I don't have the capability to answer about 5G or something, but one thing I know about any technology is we have to learn to adopt to it. Whether it is a boon or bane is something that we have to come to terms to it as at the earliest. I think one place where we are doing very well as a country is in the fintech area and our mobile phone penetration. If companies can come together to actually get technology of the supply chains, that is and the thing which I personally work a lot on food supply chains. And if you are able, because a mobile phone is something that is available right from a farmer to an end consumer. If you are able to integrate the information that is available at a farmer to the consumer, that by information I mean the quantities that are produced to the price that a consumer pays, I'm sure that a lot of inefficiencies in the supply chains can be ironed out. 5G is a reality waiting to happen, and I do not know whether I cannot comment at this point whether it would be a boon or a bane.
Thank you, ma'am.
Thank you.
Participants, any questions? Yeah. Then I think you can email us or we'll communicate with ma'am if there are any queries.
Thank you.
Thank you, ma'am, and really thankful for giving this time for us. We know it's late.
My pleasure, and I thank you for inviting me. I hope I met the whatever was
really enjoyed the session, ma'am. Thank you very much, ma'am. Thank you.
Thank you. Thanks a lot.
Thank you. Participants, thank you for the kind attention. So we'll wind up this session. Thank you all. If any queries or concerns, please do share. Thank you. So we'll wind up the session. Thank you all.